Hey, my name is Felipe and welcome to my channel. In this video, I'm going to show you how to train Yolov9 on your own custom dataset in an EC2 instance in AWS. We will be using a GPU-based EC2 instance in AWS, and we are going to combine two of my previous tutorials. My previous tutorial where I show you how to train Yolov9 in a Google Colab, and also my previous tutorial where I show you how to train Yolov8 in an EC2 instance in AWS. We will be somehow combining these two tutorials together, and I'm going to show you how to train Yolov9 in an EC2 instance in AWS. So this is Yolov9 official repository, but we are not going to use this repository, but we are going to use a fork I made from this repository. You can see that this is my account, this is my GitHub account. The repository is called Yolov9 and it says forked from the Yolov9 official repository. This is the repository we will be using in this tutorial. And I created this fork because I made this file over here, which is called yolov9.py, and this file has some functions and some classes and a lot of code that's going to help us a lot in order to simplify this training process, and you're going to see exactly how later on this tutorial. But for now, let's continue. So we're going to train this object detector using Yolov9, and now let's get started by launching the EC2 instance we are going to use to train this object detector. So I'm going to select this option over here, which is EC2. You can see that I'm already logged into my AWS account. So this is obviously the first step in this process. You need to log into your AWS account. Then you need to go to EC2 and you need to launch instance. The name of this instance will be something like train Yolov9 custom data. Then I'm going to select Ubuntu. Then the instance type will be G4 DN X large. And something that's very important is that everything we are going to do today in this tutorial is not free. Absolutely every single product, every single service we use in AWS is not free, but we need to pay for it. This is very important. So if you follow along this tutorial, you will need to pay for all the services and all the products you are going to use in AWS. For example, this instance we are going to launch now, you can see that these are the prices for using this instance. We are going to use this instance with Ubuntu, so this is going to be on-demand Linux-based pricing, 0.52 dollars an hour. So this is the overall pricing of using this EC2 instance, and obviously there may be other charges as well, so just keep in mind that this is not free, but you will need to pay for it. Then key pair, and I'm going to select my key pair. If you do not have a key pair, this is time for you to create a new key pair, but in my case I already have one, so I have just selected my key pair. Then I am going to configure storage and I'm going to set it in 50, and this is going to be pretty much all in order to launch this instance. So I click here on launch instance, and the only thing we need to do now is to wait until this instance is launched. Okay, and now we are going to click here and we are going to SSH into this EC2 instance. So let me show you. I have already selected this instance over here, and I'm going to copy this value, which is the public IPv4 DNS. I'm going to copy this value and I'm going to open a terminal. And I'm going to say something like this: SSH over here, copy paste, and then Ubuntu add, and I'm going to copy this value over here. Okay, yes. Okay, so I am logged into this EC2 instance, and the first step we need to take is to install the CUDA drivers, because remember, we are going to be using a GPU-based EC2 instance, and the reason we are using this GPU-based instance is because we want to speed up the training process, so we want to use the GPU. And in order to use the GPU, we will need to install the CUDA drivers, and in order to do so, the only thing we need to do is to execute these 4 instructions we have over here. So the only thing I'm going to do now is to execute these 4 instructions one at a time, and that's going to be pretty much all, and I'm just going to resume the video once this is completed. Okay, and now I'm going to execute sudo reboot, And this is going to log out of this EC2 instance, and now we need to wait a few minutes before we SSH back into the EC2 instance. And in the meanwhile, let me show you the data we will be using in this tutorial. We're going to use exactly the same dataset we used in my previous video where I show you how to train Yolov9 in a Google Colab. Exactly the same data, exactly the same dataset, absolutely everything is going to be exactly the same. So the only thing I'm going to do in this tutorial is to take this file data.zip, and I'm just going to use this file in order to train the model. If you want to have more details regarding this dataset, regarding the file structure of the data we will be using today, regarding everything that's involved in this dataset, then I invite you to take a look at this video, this previous video about how to train Yolov9 in a Google Colab, because in this previous video I show you all the details of everything that's involved with this dataset. If you want to have more details, please take a look at this video over here. But in this tutorial, in the tutorial you are currently watching, the only thing we're going to do is to take this file and we're just going to use it in order to train the model. So let's SSH back into the EC2 instance again. Let's see if this is ready. Yes, everything is ready. So the first thing I'm going to do is to create a virtual environment, because we are going to install many Python packages and it's always a very good practice to work on a virtual environment. So I'm installing virtual env, and now we are going to create a new virtual environment by executing something like this: virtual env bemp python 3. Okay. Now I'm going to activate this virtual environment. And the first thing I'm going to do is to download this dataset. And as this dataset is in my Google Drive, the easiest way to download this dataset into my EC2 instance will be using a Python library which is called gdown. We will be using this Python library over here, gdown. So let me show you how to do it. I'm just going to install pip install gdown. And then the only thing we need is this file ID. And in order to get the ID, we are going to do a couple of things. We are going to share, I'm going to make it a public file. I'm going to make it publicly available. And then I'm going to copy the link. I'm going to open a text editor. And I'm going to get this ID over here. I'm going to copy this number and I'm going to execute gdown and then the ID. And this should be enough in order to download this data into the EC2 instance, and that's it. Now this you can see that this is a zip file, so this is a compressed file. This is compressed, so we need to uncompress this file. And in order to do so, we are going to use unzip. And obviously we need to install unzip first. And this is how we're going to do it. Okay, this was very quick. Now we're going to call unzip data.zip, and the destination will be the current directory. Okay, and that's pretty much all. You can see that we are uncompressing all this data into the EC2 instance. Now let's continue. Now we are going to get this repository, the one I cloned, the one I forked from Yolov9. This repository over here, we are going to clone this repository, and we are going to keep on working with this repository in the EC2 instance. So I'm going to say something like this: git clone and the repository URL. Then we are going to change directory into this repository. Okay, and now we're going to install all the requirements by calling pip install -r requirements. Okay, so now we're installing all the requirements which are over here in this file, which is called requirements.txt. And this is going to take a couple of minutes, so I'm going to resume the video once this is completed. Okay, so the requirements have been installed, and now although we are using a GPU-based EC2 instance and we have installed the CUDA drivers and we have installed all these requirements over here, we still need to make sure that PyTorch is using the GPU. This repository, Yolov9, this amazing repository, this amazing technology, uses PyTorch under the hood in order to do all the deep learning related stuff, right? It uses PyTorch under the hood, so we need to make sure that that PyTorch is using the GPU. And this is what we are going to do. We are going to call Python. So now we are running a Python environment. We are going to import torch and we are going to execute an instruction, which I never remember exactly how it is. So I'm going to search something like this. Check if PyTorch, how to check if PyTorch is using GPU, and this is exactly the instruction we need to execute. And you can see that we have this error over here, which means that PyTorch is not using the GPU. So now we need to do something, which is pip install. Yeah, I think this was. Yes, we need to make a pip install, which is exactly like this. And this is going to install a very specific version of Torch, Torch Vision, Torch Audio, and so on, which is going to be exactly what we need in order to use PyTorch, in order to make PyTorch use the GPU, right? So the only thing we need to do is to execute this instruction, and this is going to install other versions of PyTorch and Torch Vision and so on, and this is exactly what we need to do now. Okay, everything seems to be ready, and now let's verify again if PyTorch is using the GPU. So let's go back over here, and I'm going to execute Python and then import torch, and then I'm just going to copy and paste this value over here. And you can see that now we get the number 0, which means everything is okay and PyTorch is using the GPU. So we can continue with the next step in this process. Now it's time to, I'm going to clear all this window and we are going to create another file, which is main.py, and this is the file we are going to use in order to do this training process. So the first step in this process will be to import from Yolov9 import Yolov9. Okay, so going back to the repository we are using, which is this one over here. This one over here. This repository we are using, which remember is a fork I created from the Yolov9 official repository, we are going to import this file, which is yolov9.py, and from this file we are going to import this class, which is called Yolov9. So remember, this is the file I created, and this is the file which is going to help us in order to simplify this training process. So let me show you. Now the only thing we need to do is to create a new variable, which is model, and model will be Yolov9, and we are going to input object detection, because we are going to train an object detector. If I show you this file again in GitHub, you can see that Yolov9 is an abstract class, and we have 3 child classes, which are called Yolov9 object detection, Yolov9 instance segmentation, and Yolov9 panoptic segmentation. So we are going to input object detection, and this is going to create a new instance of this child class, which is Yolov9 object detection, and this is going to help us in order to simplify the entire training process. So let me show you. So once we create this new variable, which is model, the only thing we need to do is to call model.train, and that's pretty much all. Once we call model.train, we are going to be executing this function we have over here, and you can see that this function executes this other function we have over here, which is going to be self-model.train. Self.model is this new instance we have created of Yolov9 object detection. So self.model.train will be calling this function over here. So we are going to be executing all this code you can see over here, which is going to take care of the training process. So by calling this function, by calling model.train, we are basically calling something like a wrapper around Yolov9, right? This is how this is going to help us in order to simplify the entire training process. The only thing we need to do now is to call model.train. We need to specify the data and the number of epochs, and that's pretty much all. that's how easy it is to train Yolov9 using this wrapper I have created over here. Now, in order to specify the data, there's something else we need to do actually, because remember we have copied the data over here, but we also need another file which I'm going to create in the same directory. I'm going to create over here, which is going to be data.yaml, and the only thing I'm going to do is to copy the content of the data.yaml we used in my previous video where I show you how to train Yolov9 from a Google Colab, which is this one over here. I'm just going to copy and I'm going to paste it over here. And we need to make a very small change, a very small edit, because now this variable over here, this key over here, which is the absolute path to our dataset, now it is going to be different. This is going to be something like home, Ubuntu, and then data, right? I'm going to save the changes, and now I'm going to change the directory. Okay, this is the directory where we have created data and data.yaml, and I'm going to print the working directory, and you can see that this is home, Ubuntu, so everything is okay. Home, Ubuntu, and data. Yeah, everything is okay. Okay, so we have created this file. Now let's get back to this repository, and I'm going to keep on editing this file, main.py, and now I'm going to specify the location of this data.yaml file we have created, which is home, Ubuntu, data.yaml. Remember, you will find all the files and absolutely everything I'm using in this tutorial, you will find it in the GitHub repository of this video. So just take a look at the description of this video and you are going to find a link to the GitHub repository, and you are going to see this data.yaml file, and you're going to see everything that we are using in this tutorial. So just bear with me, just follow along this tutorial, and later on you will find all the files in the GitHub repository. And then for the number of epochs, I'm going to make this training process for 150 epochs. This is very important. If you watched my previous video on how to train Yolov9 from a Google Colab, you will remember that we trained the object detector for 10 epochs, and at the end of the training process we noticed that this was not enough in order to make a very powerful object detector, right? In order to train a very robust, a very accurate object detector, 10 epochs was not enough. So in this case we are going to train the object detector using Yolov9 for 150 epochs, and let's see what happens, right? Because remember, we are using exactly the same data, so let's see what happens if we train exactly the same model for exactly the same with exactly the same data, but for 150 epochs instead of only 10. Let's see what happens. So I'm just going to save the changes, and that's going to be pretty much all. Something I'm going to do now, I'm going to make this training process in another screen. So I'm going to say something like this: screen. Now I'm going to activate the virtual environment again. Okay, and now I'm going to execute Python main.py, and let's see what happens. Everything is ready? Yeah, everything is ready. Let's see what happens. Okay, everything seems to be okay for now. We are loading the data, everything is okay as well. And now we are starting the training process, and we get an error. So I am going to get this error over here, and I'm going to paste it in Google. And you can see that this is obviously an error I already found when I was preparing this tutorial. So I know what's the edit we need to do, which is this one over here. We need to install another version of the Pillow library. I'm just going to copy and I'm going to paste it over here. We have already activated the virtual environment, so everything should be okay. And let's see what happens now. I'm going to make this training process again. I'm going to execute main.py. Okay, and everything seems to be working just fine, so I am just going to detach from this screen by pressing Ctrl A and then D, and then I am going to exit this EC2 instance, and the only thing I'm going to do now is to wait until this training process is completed. And once this is completed, I'm going to see all the results. I'm going to get all the results from this EC2 instance, and we are going to continue from there. Okay, now the training process is completed, and you can see that all the results were saved here in the runs directory. So now I'm going to detach from this screen, and I'm going to exit this EC2 instance, and I'm just going to clear all this terminal over here. Now what I'm going to do next is to copy all these results of the training process. I'm going to copy the entire runs directory into my local computer, and there are many ways in which we could do it, but the way I'm going to do it is by using this command, which is called scp, and this is going to work just fine in my case because I am using a Linux an OS which is based on Linux, which is Linux Mint. In your case, you may need to take a look at other similar commands, or you need to take a look at other ways to run this command depending on your OS. If you are a Windows user, or if you are a Mac user, or whatever type of user you are, please take a look at other ways in which you can execute the same command. Or also there are many other ways in which you can copy the content of the runs directory into your local computer. For example, in my previous video where I show you how to train Yolov9 from an EC2 instance in AWS, the way we did it in this tutorial was by using an S3 bucket in AWS. So in this tutorial we used an S3 bucket in order to download all the data into the EC2 instance, and in order to upload all the results from the training process back to the S3 bucket. So this is another way in which you could get all the results from the training process into your local computer. But in my case, I'm just going to run the scp command, and in order to do so, I am going to search something like this, and then I'm just going to copy something like this. Okay, and I'm just going to change this value, and then I am going to paste it over here. Okay, this is going to work just fine. Oh no, actually it's not. Because it is scp -r and then -i. Okay, now everything should work just fine. You can see we are copying all the files from my EC2 instance into my local computer, and this is going to take a couple of minutes. Okay, and after a couple of minutes, I got this directory over here, which is the runs directory. Now I'm going to open this directory, and you can see that these are all the results from this training process. So let's see what happened. I'm going to open this file over here, which is results.png, and you can see that this is a summary of all the training process and everything that happened in all these 150 epochs. And something which is very important is, please mind these 3 plots over here. You can see that these 3 plots are always 0 in all the 150 epochs. So this means we don't have the information of the loss in the validation set. And this happens for some reason in this repository, and there are other people who are talking about this in the issues of Yolov9 official repository. For example, this one over here, which says validation loss is 0, and then the author of this repository say, yeah, the currently calculation of validation loss is closed when using this Python file, which is the one we used in order to train this model. So long story short, these plots, these 3 plots you can see over here, this is going to be 0 when training Yolov9 the way we are training it right now. So we don't have access to this information over here, which is the validation loss, but we do have access to everything else, so we can just take a look at everything else in order to validate this training process. Regarding the loss in the training set, we can see that the loss, especially this one, which is the loss which is related to the object detection, right, to the bounding boxes, you can see that this loss goes down as we increase the number of epochs, which is exactly what should happen. So everything looks okay so far. And if we look at these other plots over here, precision, recall, and mean average precision, you can see that everything goes up as we increase the number of epochs. So everything looks okay as well, right? The validation loss provides a lot of information because this is actually the most important plot when validating an object detector, when validating the training process of an object detector. But nevertheless, we can take a look at everything else and everything seems to be okay. And now let's take a look at how it performs with some very specific examples. So I'm going to open this file over here, this image over here, which is val batch 0 labels, and these are a few examples of the validation set of the data we are using in order to validate the performance of this model. Remember, this is data we didn't use during the training process, but this is data we are using only to validate the performance of this model we trained. So all the red bounding boxes you can see over here are the annotations, the labels, and then if I show you this other image, the red bounding boxes we are currently looking at, these are our predictions. These are the predictions we got with the model we trained, and you can see that we are getting some very decent predictions, right? We are able to detect pretty much all the ducks we can see over here, right? Remember, these are the annotations, so this is the ground truth, and these are our predictions. I will say we are getting some very decent results. Now let's take a look at our examples. These are the annotations, these are the predictions, and you can see that we are getting some very good results as well. So this is only to show you a very quick way to evaluate the performance of the model you trained, and this is going to be pretty much all for this tutorial. So this is exactly how you can train an object detector with Yolov9 in an EC2 instance in AWS, and this is going to be all for today. Please take a look at my other videos on Yolov9 because I also show you other ways to make predictions with Yolov9, and I show you many different tutorials and many different projects using this amazing technology which is Yolov9. This is going to be all for today. My name is Felipe, I'm a computer vision engineer, and see you on my next video.